to polynomials. So we'll start off by defining terms. Terms are single numbers or products of numbers and variables. So for instance, -4, -x squared, 9y cubed, z squared, -24a cubed, b c squared. These are all terms. Notice nothing's being added or subtracted. Everything's being multiplied. Coefficients are the numbers, the numerical factors of a term. So from these examples of terms, we have the coefficients -4, -1, 9, and -24. Okay. The degree, we'll talk a little more about the degree later, but the degree of x is equal to 1 because the exponent is a 1. The degree of x squared is 2 because the exponent is 2. The degree of -9 x to the 12th is 12 because the exponent is 12. When you have multiple variables, then you have to add exponents. So the degree of xy is, well, this is the degree of x times y is the degree of x to the first times y to the first, which is 1 plus 1, so 2. And similarly, the degree of x squared y cubed is 2 plus 3 from the exponents of 2 and 3, which is 5. So monomial, well, here's a good list of monomials back here. Terms and monomials are equivalent. Binomials are when you have exactly two terms. So x squared plus y squared, 7a minus 4b, x squared minus 2xy plus y squared. These are binomials. This is not. Why? Because there's three terms. Alright. It is a trinomial, though. We could put it down here. So, examples. This is an example of a trinomial because it has three terms. try being the prefix for 3, grouping of 3. Another example, x to the 4th minus 2x squared y squared plus y to the 4th. I'll give these some coefficients. So 2x to the 4th minus 4x squared y squared plus 3y to the 4th. So it's the 3 terms that makes it a trinomial. A polynomial is a many-termed mathematical expression. So an example might be 7x to the 5th minus 3x to the 4th plus 9x cubed minus 6x squared plus x minus 5. It has coefficients of 7, negative 3, 9, negative 6, 1, negative 5. Ascending and descending powers. We want to combine any like terms our polynomial might have and arrange them in a descending order so that the powers are getting smaller as you move from left to right. So on the following example, we want to combine like terms. And arrange them in descending order. And we have 9x cubed plus 12x minus 7x squared minus x plus 6x cubed plus 8 minus 4x squared minus 9. Okay. Well, look at these x cubed terms here and here. And then notice these x squared terms. And these x terms. And finally, these constant terms. We group them together. We have 9x cubed plus 6x cubed and then minus 7x squared minus 4x squared for the the x terms, plus 12x minus x and then plus 8 minus 9 in constant terms. Then 9 plus 6 is 15, so 15x cubed. Negative 7 minus 4, negative 11 x squared. 12 minus 1 is 11x. 8 minus 9, negative 1. And that's the answer. We have a you try it in our text. And it is arrange and combine terms. Where you have 3x squared minus 5x cubed plus 8x plus 9x squared minus 7x plus 2x cubed. Alright. Notice that if we have like terms in terms of x squared here, 3x squared and 9x squared, and we have x cubes here and here, and then x terms here and here. So we don't have to arrange them before combining them. We can combine them and then arrange them. So negative 5x cubed plus 2x cubed is negative 5 plus 2. Well, maybe we'll arrange them this one last time. Minus 5x cubed plus 2x cubed and the x squared terms plus 3x squared minus plus 9x squared. And the x terms, 8x minus 7x. Negative 5 plus 2 is negative 3, so negative 3x cubed. 3 plus 9, 12. 12x squared. 8 minus 7, 1. So plus 1x or plus x. Alright. We've already defined the degree. So combining, let's do another example of arrange and combine like terms. And we have a cubed plus 5a squared b plus 3b squared a minus b cubed plus 7a squared b minus 8b squared a minus 2a cubed. Right, so first things, we have an a cubed, and we scan through and see no other a cubes. Oh, but we do at the very end. So a cubed minus 2a cubed. And then a squared b. This is b squared a. It's different. B squared. So different terms. B cubed. A squared b. There's another a squared b term here. 5a squared b and 7a squared b. So plus 5a squared b plus 7a squared b. And then b squared a. Well, b cubed, different terms. B squared a. So b squared a. B squared a. So plus 3b squared a minus 8b squared a. And what's left? A minus b cubed. And this is 1a cubed, so 1 minus 2, negative a cubed. 5 plus 7, so 12, a squared b. 3 minus 8 minus 5, b squared a. And minus b cubed. Alright, none of these terms are like terms, so this is the final answer. And there's a sort of, set in stone way. Here we have A's arranged in descending order, and that's pretty common. So A is the first, A is the first letter before B. It's the first letter in the alphabet. So you can do a alphabetic sequence convention or a increasing subscript convention. It depends on the book. So we have a U try. From our book, I believe. Combine like terms. Negative 4x squared y squared plus 3x cubed y plus 6x cubed y minus xy cubed plus 2x squared y squared. Okay. We start here, moving left to right, x squared y squared, and here's an x squared y squared. So it's 4 plus negative 4. So we need the sign of the numerical of the coefficient. Minus 4 plus 2 is minus 2, so minus 2x squared y squared. And here, x cubed y, we have an x cubed y here. So it's positive 3 plus 6, which is 3 plus 6, so 9. 9x cubed y. And then minus xy cubed is by itself. Alright. Polynomial functions. So, a polynomial function is a rule or a map that assigns to each domain object a range object defined by a polynomial expression. So some examples. Here's an example. P of x equal to x cubed plus x squared plus 8x minus 3. So find the polynomial evaluated at -2. This is our polynomial function. Right? So we have step 1, replace the variable with empty parentheses. Step 2, fill in the number you're evaluating. And simplify, combine like terms. -2 cubed is -8, whereas -2 squared is +4, because negative number to an odd exponent is negative. Negative number to even is positive. 8 times -2 minus 16 and minus 3. Well, -8 plus 4 is -4 minus 16 minus 3, which is minus 23. Okay, now you try. Your polynomial is 2x squared plus 3x plus 7. Evaluate at x equals 3. Alright, pause the video and give it a try. Right, so replace the variables with empty parentheses and then plug in the value we're evaluating the polynomial function with. And then we use our order of operations and get 2 times 9 plus 9 plus 7. So 18 plus 16, which is 34. Alright, so the graph of a polynomial function. This is the sort of the standard form of a quadratic polynomial. You have a polynomial function, p of x, and then you have x squared plus bx plus c. So here we are going to, let's graph let's do y equals x squared minus 2x plus 2. Alright, so we can make a chart. And then pick some values. How about negative 2, negative 1, 0, 1, and 2. And how about 3 on the x-axis. Okay, so when x is negative 2, then we get negative 2 squared minus 2 times negative 2 plus 2. So that's 4 plus 4 plus 2, so 10. So that's negative 2, comma 10. Negative 1, we have negative 1 squared minus 2 times negative 1 plus 2. So 1 plus 2 plus 2, 5. Negative 1, negative 1, 5. At 0, we have 0 squared minus 2 times 0 plus 2. So 0, 2. At 1, we have 1 squared minus 2 times 1 plus 2. So 1 minus 2, negative 1. Negative 1 plus 2, 1. 1 comma 1. At 2, we have 2 squared minus 2 times 2 plus 2. So 4 minus 4, 0, 0 plus 2, 2, 2 comma 2. And at 3, we have 3 squared minus 2 times 3 plus 2. So 9 minus 6, 3. 3 plus 2, 5. 3 comma 5. Alright, so negative 2, 10. That gets us, here's negative 2. Here's 10. So point there. And negative 1, 5. So negative 1, and 4, 6, so 5. Negative 1, 5, 0, 2. Okay, 0, 2. 1, 1. Here's 1, 0, 2. Here's 1, 1, 1. And then 2, 2. Here's 2, here's 2. And 3, 5. Here's 3. And here's 5. And sure enough, if we were to compute 4, we would get 10 as well. Let's just do it. Here's 4. So 4 squared, 16, minus 2 times 4, 16, minus 8, 8. 8 plus 2, 10. So 4, comma 10. Alright, and then if you look at this, if we were to graph more points, we would see that it curves like a U shape. Like so. I kind of fudged it there. I'll draw it again. Alright, going this way. Like so. And we can label it y equals x squared minus 2x plus 2. At this point, negative 2, 10, negative 1, 5, 0, 2, 1, 1, 2, 2, 3, 5. So all of these functions of this form, ax squared plus bx plus c, like here, in this case, a is equal to 1, b is, well, plus is built into the formula, so b is negative 2, and c is 2. Anything of that form is going to have this U-shaped parabola graph. So here's a couple examples. Negative 2x squared plus 5x minus 4, and 2x squared plus 3x plus 4. So notice the negative. Negative next to the x squared term. So concave down. So you could think of it as it frowns or water would fall out. It opens. Informally, we'd say opens downward. Right? Because our a here, negative 2, is less than 0. So the parabola opens downward when a is less than 0. Here, a is 2. So it opens upward. If a is greater than 0. So it holds water, you can informally think. And we have here in the notes that if a is greater than 0, opens upward, a less than 0 opens downward. This turning point here, this is the vertex. There and there. So that is the maximum or minimum point. So let's graph p of x equals negative 2x squared plus 7x plus 1. Go ahead and pause the video and give it a try. Alright, so you have several ways of doing this. If you were to type it into your calculator, generate a chart, then you would get let's say if we start at negative 2, go negative 1, 0, 1, 2, because you generally want about at least 5 points for a parabola. Then we would have negative 21, negative 8, 1, 6, 7. Or we have negative 3. Alright, so negative 2, that's off the charts. Negative 1, also off the charts. 0, we're at 1. Here. At 2, 1, we're already at 6. Right there. At 2, we're at 7. Right there. At 3, we are at 4. And at 4, we're at negative 3. Down here. It's not clear what the vertex is, but I can tell you that it is 7/4, which is just about here. It's somewhere up here. And more on finding vertexes later. Right. This is a case where you might think that this point is the vertex because it has the largest y coordinate, but really the vertex was a little bit, oops, little bit before that point here. Alright. And let's label it p of x equals negative 2x squared plus 7x plus 1. And we have our y-axis and our x-axis. And so here is a computer graph of the same function. This is p of x equals negative 2x squared plus 7x plus 1. And notice here's 2, and the vertex is, yes, just a bit before 2, 7/4. Alright, so here's some tips on graphing polynomials that you can go on at your leisure. And you as well do your homework. Now we'll do a few exercises from the text. Let's look at 4. State the coefficient. Coefficient negative 5. Degree 3. So for 5, coefficient is 2, and degree is 7, 4, and 5 added together. Which is 16. Alright, now let's look at 10 and 13. So for 10, state whether the expression is a monomial, binomial, or trinomial. Well, we have two terms, so binomial. Let's not do 13 and do 15 instead. And here we have three terms, three things separated by plus or minus signs. So trinomial. Alright, now let's tackle something like 20. So suppose that we had 5x to the 9th minus 8x to the 12th minus 19 2x to the 15th plus 2x to the 22nd. So descending means left to right, highest degree first. And so here we have 2x to the 22nd, and then minus 19x to the 15th, then minus 8x squared, or 8x to the 12th, and then plus 5x to the 9th. If we were to get 19 into order, we would have 2x cubed, or 2x to the 15th, and then minus 3x to the 11th, and then plus 8x to the 6th, and then lastly minus 2x squared. There you go. So sort each of the given polynomials in ascending powers of x. So ascending means increasing from left to right. So for 21, we would have 3x to the 4th, and then minus 2x to the 12th, then plus 8x to the 14th, and plus 7x to the 17th. Here we want to simplify and combine like terms and arrange in descending powers. So let's do 28. So negative 8x cubed minus 2x squared minus 7x minus 3 plus 7x cubed minus 9x squared minus 8x plus 9. So we underline like terms. And group them together. Negative 8x cubed plus 7x cubed minus 2x squared minus 9x squared minus 7x minus 8x minus 3 plus 9. And negative 8 plus 7, negative x cubed, negative 2 minus 9, negative 11x squared, negative 7 minus 8, negative 15x, negative 3 plus 9, plus 6. And everything's in descending order from our grouping operations. Okay. Let's do another example. How about 36 here? So 7a cubed plus 6a squared b minus 5ab squared plus 4a cubed plus 6a squared b plus 6b cubed. So here's an a cubed and here's an a cubed. A squared b, a squared b, ab squared, no ab squareds, and no other b cubes. So 7 and 4, 7 plus 4, 11, a cubed, and 6a squared plus 6a squared b plus 6a squared b is 12, a squared b. And then we have, let's see, let's put the minus 5ab squared next, and then plus 6b cubed. So we have descending powers of a cubed, a squared, a to the first, a to the 0. When there's no variable, you can say the variable is to the 0 power there. State the degree of the given polynomial. Let's look at 47. So the degree is 18, because that's the max exponent. So the maximum exponent is the degree when it's just one variable. Alright, so we'll look at using our calculator in class to graph and evaluate functions. And that concludes this lecture.